All right, let me quickly recap what we did in point 2/5. We said कि भाई whenever the user clicks on add money button, a recent transaction should be added. How did we do that? We added an action in lib/actions/create on-ramp transactions that puts an entry in the database anytime the button is clicked on the front end. This specific function call happens on the server and actually puts an entry in the database with a status set as processing. Notice we do not increase the balance of the user. If I go here and put 20,000 rupees and click on add money, we don't increase the balance of the user immediately. It's still 600 rupees because there is a pending request for 20,000 rupees. How will this pending request become successful? This pending request will become successful if I take the token for this specific ID. I take the amount for this specific transaction. I take the user ID who's interacting for this specific transaction, which is user number 1. And I send a request to localhost:3003, which is running my bank server. If I open Visual Studio Code, I'm running npm run dev in the bank webhook handler, which is this thing right here, which will actually increase the user's balance. If you go to source/index.ts here, you will see we increase the balance of the user by that specific amount. I now send this again. Now, if I go here and refresh, you will see 20,600 rupees. The balance got added over here. There are a few bugs over here, which you should fix. Number 1, what happens if I resend the request? What happens if I resend the request? The user now has 40,000 rupees. Should not happen. This only happened once. How can you fix this? You should have a check over here. Check if this on-ramp transaction is all processing or not. Only if it is processing should you increase the balance by 20,000, else you shouldn't. All right. Bunch of these edge cases you will find from time to time that I'm pointing out and you should fix. Cool. Given that issue number 1 is done, given that if I go to CMS, not CMS, if I go to the repository for today, which was, let me go back here. The repository for today was week 17 final code, which is the final code of last week. This transaction is done, or this issue is done. Now let's move on to issue number 2, which is allow users to send money to each other. Given that this user has so much money, 40,000 rupees now, they should be allowed to send it to their friend, right? So the next step was add a 4th UI column over here. If you go to the next slide, 3 out of 5, add a P2P transfers column over here. How would I, from first principles understand how do I add a new column over here given the UI only has 3 of them? I would search through the UI for transactions, or I would go to the /transfer page. Let's go from even simpler first principles. I would go to the code of /transfer. You open Visual Studio Code, transfer/page.tsx. If I open transfer/page.tsx, if I look at the final div that is returned, it says transfer at the top. It says transfer over here. And then it renders the add money component, this component right here, everything else. So it seems like, this /transfer only has the code for whatever is on the right. This left sidebar code is not even present in page.tsx. Can you guess why that is happening? Why does page.tsx, which is the handler of /transfer, if you look at this, it says transfer/page.tsx, transfer/page.tsx. This, if I write hi over here, you see hi over here. Where is the code of this sidebar on the left? Where is the code of the app bar? And the answer is in layout.tsx. The global layout.tsx, renders the app bar and then renders everything else, which is why we see the app bar here. And then there is another layout.tsx. I repeat, there is another layout.tsx over here. Where is it? If you look at the folder structure, it is in app/circular braces dashboard circular braces, which if you remember from the Next.js classes means, all of these will share this layout and the URL will not have dashboard. The URL simply has /transfer or slash transactions or slash dashboard based on where you have clicked. But all of them will share this layout. If I open this layout, is where you will see, okay, acha, this renders a left sidebar and on the right renders everything else, which is why here is where I need to add a fourth entry. Okay, by on slash P2P with what icon? I need a new icon that I can put over here. This has a clock icon. This has a share icon. I can repeat this icon as well if need be. Let's do that for now. Repeat the transfer icon and title can be P2P transactions. If I save this, is that enough? Let's see. If I refresh, I do see P2P transactions over here. It became a little longer, so I'd probably rename it to P2P transfers. Transfer. And then I also want to change the icon. All of these icons, as you can see, come from heroicons.net. So you can go to heroicons.net or .com and search for a new sort of icon. Let's say this icon is what I like, arrow trending up. I can copy the SVG for it and I can go back to my code, create a new component called P2P transfer icon. Returns this SVG. Replace class with class name, and I will use this P2P transfer icon in my sidebar item for this. Now if I save this and go back to the page, you will see this has a nice icon. I have a P2P transfer thingy. The problem is if I click on this, the user goes to slash P2P, which is, what I'm passing as a href over here. Href means, take the user over here, but there is no handler for this page. So next up, I need to create a P2P slash page.tsx, which will export a function default function return div that says P2P page. If I save this and if I refresh now, you will see I have the P2P page added with all the rest of the pages. Only the transfer page has something right now. Everything else is, fairly messed up. Just empty pages. But P2P transfer we will implement. We will implement something like this over here. A card in the center that lets you put someone's phone number, put the amount that you want to send them, click on the send button and transfer that much money to their account. Let's try that out. I'm going to copy a bunch of code, specifically the send card.tsx, which is this card code right here, but it should be fairly easy for you to write because as you can see, we're just importing all the components we have already written. Last week, we wrote all of these components. We're just reusing these components now to create a very pretty, not very pretty, but you get the idea, pretty-ish card. So I'm going to add this component now. You can create this yourself also if you want to, not copy code. Send money.tsx. Let me paste this. Send card, sorry. Feel free to name it whatever you want, but let's do send card. And now, given this send card has been created, where should I be rendering it? I should be rendering it in P2P. Need to import it. And now if I look at the page, it looks something like this. It's not horizontally aligned. That probably is because this needs to be full width, class name equal to w-full. There we go. Now we have a centrally aligned page. It has a number which is being set in the state variable. It has an amount which is being set in the state variable. I need to handle what happens when I click on this button. Can we create another server action now? What do we want? We want, by given this number and account, this user wants to send the money to this number, this much money. So can we do another server component, not server component, another server action in app/lib/actions/ let's call it transfer.ts, or you can call it something else as well. Let me see what we call it over here. Let's keep the naming conventions fairly similar. P2P transfer.ts. Let me create a P2P transfer.ts file. And here I'm going to copy this code and take you through it, not writing it from scratch. What does the server action do? It takes two inputs. The user that you want to send the money to, their phone number. Basically, this 2 is their phone number. It is not their ID, it is their phone number, because that is what you see in the UI over here. The user will write their phone number and the amount that they want to send. Given these two, we first extract the details of the user. And if this user does not exist, for some reason this user isn't logged in, we return to the front end error while sending money. If the user does exist, the from user does exist, we get the details of the to user. We say, by who is this user who has this specific number, because this number is their phone number. We want the user's actual ID. So we fetch the details of the user. And if the user doesn't exist, then also we say user not found. Given that the from user exists and the to user exists, what do we need to do next? We need to decrease the balance of the first user, increase the balance of the second user. But we need to make sure the user has that much money. The user needs to at least have amount of money, which means, whatever they're trying to send. I cannot write, 1 million over here if I only have 40,600. If I write 1 million over here and click on send, the backend should block me. And that is exactly what happens here. Here we check, okay, by how much balance does the user already have? The from balance is the user of the person who's trying to send the money. Transaction.balance.find unique. What is this transaction here? Ignore this line and this line for now. Ignore these for now. Assume this says Prisma. Let's look at all the Prisma DB calls, and then eventually we'll look at what this transaction is and why we need it. We first check, does this user have enough balance? If they don't, we throw a new error, or we can simply return a message as well. You don't have enough money. Either is fine. If they do have that much money though, then we update the user's balances. The problem is we want either all 4 of them to happen together or none of them to happen. If only these 3 happen and this doesn't happen, then I would have lost 200 rupees, but my friend will not have received the 200 rupees. Harkirat, why would it happen? Why would this happen but this not happen? Let's say your server went down. Let's say your control reached here, server went down. Then the user will have a balance deduction, but the other person will not get the money, which is why you wrap it inside a transaction. You say Prisma.dollar transaction. I'm creating a transaction. Anything that you're calling should not be called with Prisma.balance, should be called with TX.balance. Okay, this transaction will do 4 things. Either all 4 will happen or none will happen. You cannot partially execute a transaction. That is what a property of a transaction is. So that is what's happening over here. We're updating the balance of the user. We're updating the balance of the other user. And we're doing a check. And all of these will happen. Either all of them or none will happen. This looks great, right? This seems like we have solved every problem that there might be. There is still a very big bug here, and we'll see what that is. But let's see if this works. We have written this function, P2P transfer. Let's call this function in send card. I need to call await P2P transfer. Let's make this an async function with what are the 2 inputs? Number of the user and the amount into 100 again, because from the front end itself we're sending like the Pesa amounts. Let me import this and let's see what happens if I go back here. If I go back here and how much money do I have right now? 40,600. If I go to P2P transfers and say 20,000, I will send to the user with number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is another user, Bob, that we have in a database. If I go here, go to the users, you will see I have 2 users, one with this number, one with this number. This is the person that I'm sending the money to. Right now, what are the balances? First person has this much money. Bob only has 20 rupees. This person has 40,600 rupees. Let's see what happens when I send 20,000 rupees to Bob. Network, send. You will see there's a 500 status code. Let's open the terminal. Let's see what the error is. The error says TX is not defined wherever I'm doing from balance equal to. Probably forgot to save this file. This file isn't saved. That's why there is, a big gola over here. So I will save this. And as you can see, the Gola went away. Yeah, I will save this and then I will retry it, send. And this time, as you can see, the request returns a status code of 200, which probably means the transfer has happened. Let me go back to transfer page. As you can see, I only have 20,600 rupees now, which means where did my 20,000 rupees go? They went to Bob. Now we are both pretty similar. I have 20,600 rupees. He has 20,020 rupees. What if I send him more 20,000 rupees? Probably shouldn't. Let me just send him 10 more rupees. 2. What if I send him 10 more rupees? Send. You will see in the database, I will go down by rupees 10 and they will go up by rupees 10. So this is great. This might feel like you've hit nirvana and you don't have any more issues. But the problem is that there is still a very big bug. Let's try to simulate that bug. Let me just first maybe share a little bit of what that bug would be. You have a backend server. And then what is that backend server doing? Allowing users to change their balances. Specifically, if I have rupees 200, I can do a minus 100 on this. There are of course a bunch of other things. I'm also doing a plus 100 on someone else's database or someone else's balance, but I'm allowing the front end or the user on the front end to talk to a backend that updates the database like this. What if this user sends a lot of requests at the same time? Okay, bhai, send 100 rupees to person 1, person 2, person 3, person 4. Will this check that we have, the from balance check that we have, will this run sequentially or will this run parallelly for all 4 of these? Let's see. The first request came. Control reached here. Bunch of checks happened. Let's say control reached here. Let's say this got stuck for 10 seconds. I repeat, this await call is happening. It's taking 10 seconds. While this is taking 10 seconds, since this is an asynchronous function, it's waiting for the database to respond. While this is happening, another request came. The second request came. That request also went through all these steps and reached over here. And then same for the third one and same for the fourth one, which means all 4 of them are stuck over here. And then all 4 of them proceed over here. And for all 4 of them, the balance of the user is 200, which is more than what you're debiting, 100 rupees. And hence, all 4 of them are able to bypass this check. And you do this 4 times. You debit 100 rupees 4 times from a user who only has 200 rupees, which means their final balance becomes minus 200. Harkirat, not able to imagine it. Sure, let's simulate this via code. Let's add a small sleep over here. Not exactly a sleep. We're not making the thread sleep. We're just making the thread wait over here for 4 seconds. Await new promise. Resolve. Set timeout. Resolve 4000. This basically means simulate, some expensive operation is happening for 4 seconds. That is not happening on the main thread. So the thread can do another thing. And the thread is sort of stuck here. Let me put a log over here. It says console.log above sleep. Then let me put another one here after sleep. Okay. Nothing much changed. I've only added 3 more lines of code. I'm just simulating. Okay, what if this request took a lot of time? I'm just adding some more delay to this request because you cannot predict how much time it takes for a request to come back from a database. Could take 1 second, could take 20 seconds. So add some simulation here and let's go to the front end and send a request. Now let me refresh the logs, put them on the side. Let me open the front end here in 2 tabs. The front end is open in 2 tabs. The backend, the Next.js server is running over here. Let me go to P2P transfer on the first tab, P2P transfer in the second tab. Number remains the same. A lot of 2s over here, a lot of 2s over here. Amount, how much money do I have left? Let's see. I only have 20,590. So let me be like, okay, bhai, I'm going to send 20,000 rupees twice. One from first tab, one from the second tab. I will very quickly try to send this money twice. Ideally, the database should prevent the second request and this amount should not become negative. No one should ever have negative balances. Else I will just put 100 rupees in Paytm and send all of my friends 100 rupees, right? And they would owe me 100 rupees. So you have to strictly check okay, this balance never becomes negative. Let's see if that's happening or not right now. These logs will give us a lot of information. Let's go here. Let's click on send and let's click on send. Do you see this? Above sleep gets logged twice, which means both of them got their balance of 20,000 over here. Both of them got, okay, bhai, the current balance is 20,590, whatever. And both of them were then able to debit money from one account, credit money to another account, which led to the first person having a negative balance, something you never want. So is this code that we have over here safe enough? It isn't. We need to lock, I repeat, lock this row. We need to make sure only one database call can access or update this at a time. I repeat, we need to make sure 20,000. We need to make sure that only one database request can access this row at a time. Not multiple updates can happen at the same time. If one person is fetching the user's balance, another person should not be able to fetch the user's balance. If you think from first principles, you might have thought of an architecture like this. Kirat, if this is a very big problem, you can reach minus 200 balance. So here is what I will do from first principles. Whenever multiple requests come, I will put them in a queue. Okay, bhai, every request will be get put in a queue. Request 1, request 2, request 3, request 4. And I will process them sequentially. I will be like, okay, bhai, first request number 4 come. I will process it, do the database change. Let's say this is the DB. And then after this succeeds, then sequentially I'll pick number 3. After this succeeds, sequentially pick number 2, so on and so forth. You can do an architecture like this. You can, from first principles, build a queuing system and then process one by one. But databases already give you this. And also, this is a big problem because every transaction is reaching here. You can run transactions for different people parallelly. You want to make sure for the same person, they should happen sequentially. If a same person has multiple requests, all 4 of them should happen one after the other. But if different people are sending requests, then they can happen parallelly. It's fine, Doesn't matter if they can happen parallelly. They don't have to happen one after the other. So, and this approach sort of does that. It makes sure everyone's request happens one after the other, which is why this approach is bad. The better approach is, okay, you do locking at the database level. You say, okay, bhai, whenever a request comes, you'll first tell the database, okay, bhai, this row is logged. This row is logged. I am right now dealing with this row. Don't let anyone read from this row. Don't let anyone write from this row. Make them wait. So if multiple other requests come, they will wait until the first transaction is completed, and only then the second request will be able to read from the database. Until then, this won't be able to read anything from the database. That is what locking lets you do. I repeat, what does database locking let you do? It lets you lock a specific row, multiple rows, the whole database totally depends on you. But in our case, we just need to lock this one row. If I lock this first row over here, then doesn't matter how many requests are coming in, even if there are 4 requests, until the first transaction is complete, the second one will not be able to read. Until the second one is complete, third one will not be able to read, so on and so forth. Question is, how do you add locks? I theoretically understand how to add, what are locks, Kirat, and I need to lock something, but show me how to add locks in Postgres. The way to add a very basic lock, there are many ways to adding locks in databases or Postgres, and you can read about them yourself here. And if you want to, implement them yourself, the way we are going to do it is by doing this, by doing something called a for update query. Whenever you select a certain amount of rows, for update, you lock those rows. I repeat, whenever you select a certain amount of rows, for update, you lock those rows. And now, until all of these succeed, no one else can, read from those specific rows. No one else can, do a parallel read on that specific row, which is why if I add this line of code, let me quickly add it. Okay, bhai, before doing anything else, before checking any balances, this row needs to be locked. Select star from balance where user ID equal to this thing needs to be locked. Kirat, why are you doing a query raw? What is a query raw? Unfortunately, Prisma doesn't support locks out of the box, which is why you have to send a raw SQL query directly, which currently seems SQL injectable, so you should fix it. But we're directly sending a raw query to the database that will lock the specific row which meets this condition until this complete transaction either succeeds or fails. Which is why if I now look at the logs, I'll now send request 2 more times and we'll see when does above sleep come, when does after sleep come, and that will give you an idea of how this fixed the problem. Let me again put the logs here on the left. I've added the line of code, put these on the right. Let me again try the shady thing of going here and then going to P2P transfers, selecting the number and then selecting the amount of 20,000, putting the number, selecting the amount of 20,000. And now let me open the network tab also, both the places. Open the network tab here, open the network tab here. And let me send both of them really quickly. Seems like if you open it one place, it closes another place. Network tab. Okay, I have it open in both of them. Moment of truth, sending 20,000 rupees from 2 tabs. When the balance of the user only is, if I'll open Prisma, how much balance does the user have? Only 20,000 rupees. I'm trying to send the same amount twice. Send. Notice above sleep came, the second above sleep did not come. Until after sleep did not happen, the next above sleep did not come. I was able to sequentially send requests. And if you look at the second request, it fails with insufficient funds. Let me repeat. What am I doing? If the same user is sending requests very, very fast, they are now happening sequentially. First, above sleep got rendered for the first one. Then after sleep got rendered for the first one. When the whole thing rendered, all the transactions, all the SQL queries happened, is when the second one's control reached here and then control reached here. Above sleep, after sleep, above sleep, after sleep. How was this before? If you remember, in the previous approach, it was above sleep, and then after sleep, after sleep. They were happening together. They were happening concurrently. They were happening parallelly. How are they happening right now? Sequentially, one after the other. Now, if I look at the balance, it did not become negative. It reached 0 because it had 20,000 rupees. I took out 20,000 rupees. Did not become negative. Why? Because I locked those specific rows. This specific row, I said, no one else can access this until this transaction is complete, which means all of these have happened. That is how you do balance protection in an application like this. That was sort of the big thing to learn here. Harkiyat, why did we not have to do this in MongoDB? Because in MongoDB, if you're doing a transaction, the way we were doing a transaction there, if any of the rows change between a transaction, which means if you do 2 transactions parallelly and if any row that you were accessing during a transaction changed before the transaction finally committed, it reverts the transaction. I repeat, said a few things here. In MongoDB, if you are doing a transaction very similar to this, right? If you're doing a bunch of queries together wrapped in a transaction, and while the transaction hasn't happened, while some requests are happening, another person does something similar and makes some changes, MongoDB reverts the transaction. It says like, bhai, I was trying to do something, but then the database changed, so I'm going to revert. Postgres doesn't do this. Postgres is like, okay, it's fine. If 2 people are doing it, it's fine. The first person read the balance, second person read the balance. And with the same 20,000 rupees balance, control reached here, the check succeeded, and both the user got debited twice. So Postgres doesn't automatically revert a transaction if a change happened to the database, to that rows while the transaction was happening. MongoDB does do it, which is why we did not have to do any locking in MongoDB. When we were building Paytm via MongoDB, we had to do it here. Cool. This one line is the biggest thing to learn here. There are other ways to do locks in in Postgres. There are various types of locks. There are read-only locks, read-write locks and write-only locks. A lot of times, you want to make sure that multiple people cannot write to the same thing, but they can still read. So, you can have a slightly less restrictive lock that lets multiple people read. And the only thing it prevents is multiple people writing to the same row. So there are various types of logs. We'll probably not cover this in 1-200 when we reach the database system design section. That's a brief. That was this slide. The biggest thing to learn was locks in case of an application like this. And let's see what's up next. I think that's next is fairly straightforward. If you go to slide number, that was slide 3, what we did right now. And by the end of it, you have a UI from which you can send money to other people. But we're not keeping track of all the transfers, right? We want in the end, there is a UI like this where people can see you sent money to the other person, you received money from the other person, which is why we should probably add a P2P transfer model. We should update our schema so that we can store all the P2P transactions that are happening. We probably eventually need, some sort of a card over here that shows the user all the P2P transactions they've done in the past so that they can, track. For example, they can track when they hit a bank account, when they on-ramped some money. The same thing should be allowed over here. Whenever the user sends money to someone, you should be able to track it. So for that, we will need to again update the database. We will need to add a new model called P2P transfer. We had on-ramp transfer, which is, from where all of these come from. Similarly, I'm going to add another model called P2P transfer that lets you track if this user sent this user this much money at this time. So that's what this P2P transfer model is. Whenever you're updating this and you have a relationship like this, you have to update the original user's model as well. Whenever you're adding a relationship between two models, if they are related, the entry needs to be made in both the places. Sent transfers and to user ID, and receive transfers and from user ID, or vice versa. Let's you relate both the tables. Let me take this slowly. Maybe this happened a little too quickly. From user ID and to user ID are the things that will get stored in the database. This user sent this user this much money at this time, but this data is related to the users table. From user is actually an entry that references the ID field of users, and similarly, to user is a relationship to the users table on the ID. And every user will have a bunch of on-ramp transactions, a bunch of balances. This probably should be a bunch of balances. It should be a single balance, but that's fine. It should be a one-to-one basically between user and balance, but that's fine for now. Sent transfers, what all transfers they have made, which relate to multiple entries in the P2P transfer table. Received transfers, which is all the transfers that the user has received, which again relates to the P2P transfer table over here. Given this schema, can we quickly implement the endpoints? Let me open Visual Studio Code. Let me go to schema.prisma. Let me add right above on-ramp transactions, P2P transactions, and let me update the user table to also have these two rows, send transfers and receive transfers. What is the next thing you do after you update the schema ever? You go to packages/db and do npx prisma migrate dev. You should also give it a name. I'm going to name it ads P2P transfer. And then you regenerate the client, npx prisma generate. Then one more thing you should probably do in a mono repo is do a global build, because you just changed a bunch of things in the DB package, which you might not see here unless you build. You might also see them. So this is an optional step. You probably don't need it. And even if this fails, that's fine. You might have a bunch of type errors. Now, if I go to apps/user app/the action that we had created for P2P transfers, what do I need to do? I need to be like, bhai, all of this is fine. You transfer, but please also make an entry dot P2P transfer dot create data from user ID, from to user ID, to user dot ID, amount, and then probably we can order to a number, probably is already a number, amount, and then time stamp, the current time stamp. You should also make an entry to the P2P transfers table. So you have an audit log of all the P2P transfers that have happened. If you don't do this, then your users' balances keep flipping. Okay, some person sent another person something. You have 3 rupees, they have 5 rupees. You never have a track of, how the current balances were achieved. People on ramped, you have a track of that. But people transferred, you have zero track of who transferred to who, which is why you definitely need this. Also, your users would also want to track somewhere on the website that I sent Sunil 50 rupees yesterday. So for that reason, you need to have this P2P transfers table. If I now rerun the application, apps/user app npm run dev localhost 3001. If I go to P2P transfer, and now, I don't have any money, so let me just add some money here. And if I say I'm going to send 20 rupees, I'm going to send to this number 20 rupees, then click on send. Let me send a few times. It gives me an error. From user ID is invalid because I need to convert this to a number. From needs to be converted to a number. And let's try that one more time. Send. Okay, looks good. Let me send this a few times. I've clicked this button a few times. If I go back to the database now and I check, I have to rerun npx Prisma Studio. Let me do that. Now if I check P2P transfers, you'll see there are 14 entries over here. Okay, user 1 sent user 2 20 rupees, 20 rupees, 20 rupees. If I increase this amount to 200, you will see it says it has a new entry for 200, so on and so forth. Now this is your audit log. Not just an audit log, this is also good for showing on the UI. But even if you don't show this on the UI, you still should have this audit log. You should always be able to achieve the current balances if you run all of these transactions. Okay, bhai, all the on-ramp transactions if you run, all of these transactions if you run from the start, whatever state you reach out of balances, that should be your current state of balances. This is very sort of needed for, call it audits, call it reconciliation, which basically means, from time to time you should check, okay, bhai, is there a bug? Maybe someone's, found a bug in our database. What if an employee is coming here and, updating things? Well, an employee can always just add something else over here. So maybe that's not the best example, but if you have a vulnerability, you'll be able to catch that vulnerability very quickly if you, have reconciliation that's happening. By reconciliation, I mean every 5 days, you aggregate all the on-ramp transactions, you aggregate all the P2P transfers, and you start creating the state of balances from the beginning. Okay, bhai, shuru mein everyone had zero money. Initially, everyone had zero money. Then they slowly on-ramped, they got some money, they slowly transferred, they lost some money, sent some money. And then if you have off-ramping, if you allow the user to send it back to banks, then off-ramps as well. Whatever is the final state you reach of balances is what should be here as well. That is what reconciliation means. And this is something you should do if you're a bank from time to time to make sure, there's no bug in your application. And, you can always arrive at this balances state given these on-ramp transactions and given these P2P transfers. That was it for this one. There is an assignment at the end, which is, given you already have all the data over here in P2P transactions, P2P transfers, why not show it on the UI? So this one's fairly simple. I'm leaving it as an assignment. There's probably an issue for it as well, but yeah, this is the final repository if you do all the changes. So if you do want to see what the repository finally looks like, it looks something like this. It does not have this UI change, which is something that's fairly easy to add, that you should add by exposing, either an endpoint or something else. I'm not going to share what, but that's it. That's all I had for today. And tomorrow we'll understand how you can deploy an application like this. We'll see if we'll probably use CI/CD. With that, let's end it. I'll see you guys tomorrow. Bye bye.